It's Tuesday, the 14th of May. My name is Juan Brown. You're watching the Blancolirio channel, and it's time for an aviation update. First up, the Amazon Prime 767 crash flight 3591 operated by Atlas Airways. I just got off the phone with Keith Holloway, the PAO Public Affairs Officer for the NTSB. I asked him about when are we going to get the data off of the cockpit voice recorders released to the public, and he explained that the CVR data will not be released to the public until they open the docket on this crash. Remember, an NTSB investigation can take anywhere from 12 to 18 months. The docket is usually opened about halfway through the investigation process. So 6 to 8 months from the date of the crash is when we'll see for the first time the CVR data that was recovered from Flight 3591. Now, there's a lot of speculation flying around the internet as to what happened to Flight 3591. We'll talk about that here in a minute. But first up, breaking tragic news out of Ketchikan, Alaska. Yesterday, the 13th of May, a mid-air collision took the lives of 4 people, and as of this time, 2 people are still missing. A de Havilland Beaver collided with a de Havilland Otter aircraft just 8 miles outside of Ketchikan. These are float plane aircraft that are taking tourists to see the Misty Fjords National Monument just outside of Ketchikan as part of a package deal with Princess Cruise Lines. Out of the Taquan Air Otter aircraft, 9 passengers were rescued, including the pilot, 1 passenger believed to still be missing. The Beaver had 5 passengers on board, 4 fatalities, and 1 passenger believed to be missing. Weather at the time was clear with a high overcast, light winds about 9 miles an hour out of the southwest. So condolences to all those involved in the tragic midair up in Alaska. The NTSB GO team has been fired up and is headed up there, or is probably already up there right now, starting their investigation. We'll have more on this investigation when they release their preliminary report. And in this preliminary report, I'll be looking specifically for what role new technology played in trying to prevent this accident, if it was used at all. Specifically, these aircraft have on board TCAS, Traffic Collision Avoidance Systems, and or ADSB, Automatic Dependent Surveillance, which is soon to be required on all aircraft operating in specific airspace by 2020. The Prime Air 767 crash operated by Atlas Air Cargo remains a mystery. Remember, this aircraft was on arrival to Houston, was being vectored around some weather. Everything was going ops normal. They were descending from 12,000 feet down to start their arrival, descending from 12,000 down to 3,000 feet. And at about 6,000 feet, the aircraft stopped its descent, initially began a slight climb, followed by a rather sudden nose pitch down to 49 degrees nose low, and the airspeed went from a normal 230 knots or so and accelerated up to 430 knots before impacting the ground just a mere 18 seconds later. So what is it that caused a perfectly normal and operating aircraft to plunge so quickly into the ground remains a mystery. Again, this is an older Boeing 767 aircraft. It has absolutely nothing to do with what we're talking about regarding the 737 MAX. There is no MCAS system on the Boeing 767 series of aircraft. In earlier videos on the series here on the Blancolirio channel, we ruled out a lot of the different possible speculations as to the cause of this crash, and are instead focusing on what the NTSB preliminary report indicates, that there was an elevator down input that put this aircraft into the ground. First off, regarding speculation from leaked information from the NTSB report. Leaking information from an NTSB investigation before that information has become public is a criminal offense. and the person leaking that information can get in big trouble. So that leads me to initially suspect any information that somebody says is coming out of an NTSB report before any of that information is public. Some of this so-called information includes that at about 6,000 feet, the captain reached around the throttle quadrant to select flaps 1 for the first officer who was flying the aircraft. And the Boeing 767, the left seat reaches around the throttle quadrant from behind and forward to grab the flap handle and bring it down to flaps 1 on speed, when the speed allows you to do that. Right on the throttle quadrant of the Boeing 767, and I'll show you a picture here, are the go-around buttons. The go-around buttons on the 767 are located right behind the throttle itself. On the Boeing 777, a little different system, the go-around buttons, for example, are located forward or ahead of the throttles. Here's the location of the toga switches on the 767, normally actuated with your thumb. And it's not uncommon in turbulent air to accidentally hit these switches, and I've seen it done before. So what this person is speculating is that the captain, when he went to reach around for the flap handle, he inadvertently bumped the go-around, or toga switches, take-off and go-around switches, just one of the switches on the Boeing 767 throttle quadrant. And it only takes one switch activated to engage the auto throttles to toga, or go-around power. Now, some initial reports state that the power went to full power. If you hit the toga switch one time on the Boeing 767, that should initiate a go-around that will result in a rate of climb of about 2,000 feet per minute. Power varies based on weight of the aircraft. As the engines began to spool up to a go-around power setting, that, of course, with underslung engines, resulted in a slight pitch-up moment. Again, not related to 737s, not related to MCAS. This is just the nature of underslung engines and swept-back transport series aircraft. As the power comes up, the aircraft tends to pitch up. It's assumed that the pilot, the FO pilot flying the aircraft, overreacted to this pitch-up, drastically overreacted, and shoved the nose over so far that he managed to achieve a 49-degree nose-low attitude. At that point, some of this speculation from this report flying around the internet indicates that the captain, without saying anything, without saying positive transfer of aircraft control, my aircraft, or anything like that, just hauled back on the control yoke. He hauled back on the control yoke, the left side, while the FO was pushing down on his control yoke, overreacting to the pitch-up movement of the aircraft, of the autothrottles going to go-around mode. And in that difference of power between the two control yokes, they managed to shear or override the interlock that connects the left and right yokes, and thusly the left and right elevators on the back of the 767. What we learned back in 1999 when Egypt Air crashed the Boeing 767 off the East Coast, the NTSB went deep into the 767 systems, specifically the flight control systems for the elevator, and determined that yes, in fact, the 767 elevator flight control system is designed to separate in the event that you have a jammed set of controls. With a pilot input of about 50 pounds or more, you can shear or overpower the override system and break free the left elevator from the right elevator, or the left control yoke from the right control yoke. Here's an illustration of the 767 elevator control system from the Egypt Air accident investigation report, showing the two separate left and right cable systems that operate from the left and right control yokes to the left and right sides of the elevators. Normally, of course, the elevators move up and down together based on control input, but in the event of a jam anywhere along the way in this complicated linkage, control can be regained by overpowering the breakout mechanism located between the two control columns. Power to move the elevator is provided by the triple redundancy of 3 power control units, each powered by an independent hydraulic system left, center, and right, with any one PCU having enough power to move the elevator. The inboard elevator is mechanically connected to the outboard elevator. The NTSB will need to review all the possible failure modes of this system, just as they did in the Egypt air crash, before they rule out mechanical failure. This is the actual stabilizer jack screw from Flight 3591, and it appears to be in a normally trimmed position. If this were fully trimmed full nose down, the yoke would be located at the top of the jack screw. In the event that you should shear the control column in this fashion, the Boeing flight controls, elevator controls, are designed to operate independently. So now the left control column would have control of the left elevator, and the right control column would have control of the right elevator. Well, if you have conflicting inputs, you're going to have a split elevator. Now, towards the end of the Atlas air crash, the pitch attitude of the nose went from 49 degrees to about 20 degrees, indicating that they were trying to recover the aircraft. What we're learning in general is that once you get an unusual attitude started, an extreme unusual attitude of 49 degrees nose low, this close to the ground, 6,000 feet, with speed increasing, chances are of a positive recovery are slim to nil. You need at least 8,000 feet or more to recover from this unusual attitude. So the speculative report flying around the internet goes on to give some additional information that seems pretty clear to me that the author of that information doesn't clearly understand Boeing 767 flight control systems, and thus I tend to discount the report. Nevertheless, it looks like this is shaping up to be a case of pilot error and an extreme unusual attitude recovery, and we'll know a lot more when the NTSB opens that initial docket on this accident. They release the CVR recording, and I'm particularly interested in finding out the first officer, the FO's flying history and check ride history. Okay, up next, the 737 MAX update. News reports have been out in the last week or so regarding the nomenclature of the stabilizer trim cutout switches mounted on the pilot's pedestal, and that the nomenclature on the 737 MAX for these two switches was changed slightly from the NG series of 737 aircraft. This, in general, I tend to put in the column of much ado about nothing, because regardless of the nomenclature on the switches, the procedure for runaway trim remains the same: stabilizer trim cutout switches cut out. However, this does not bode well for Boeing as to what sort of other additional information did you not tell us about the new Boeing 737 MAX aircraft. And getting ahead of the investigation as to the cozy relationship between the FAA and Boeing aircraft, I highly recommend one journalist, Dominic Gates, from the Seattle Times newspaper in Seattle, has a great series of articles following the 737 MAX story, and particularly the articles that he's come out with lately investigating how, over the years, the FAA has been steadily transferring the liability and responsibility of inspection of Boeing aircraft from the FAA to Boeing itself. And I don't want to get into that discussion now because it's a long and wonky discussion about government organizations regarding the inspection of aircraft. So stay tuned for further updates. Hit that little notifications bell if you want to get these updates in your email box or notified on your phone as soon as they come out. We'll see you here. Where's the rain?